Welcome to the Someone Somewhere podcast. It's Sunday, June 25th, and I'm your host, Nicole. This is episode 2. So some of you may know that I have been very into soil microbiology lately, and through the process of farming, I came to the process of composting and really figured out why that is the single most important element to growing good food and having great yields. So I thought I would take some time today to share with you how to compost, how I compost, and why it's important. Now, the central question is really, what is compost? Most people think compost is a fertilizer, but it's actually a little bit more complicated than that. A fertilizer would mean an additive of some nutrient that you're looking to add to the soil. Compost is different because although a lot of those nutritional pieces may come along the way, what you're really adding is diverse biological life to the soil, and you're returning it to the soil. So I like to think of it as a subterranean civilization. The basis of that civilization is sunlight. You need photosynthesis so that plants can make sugar. Over 50% of the energy of a plant is translocated to the roots, meaning they're pulling that down and it's staying in the soil. So your plant puts out what is called an exudate. Those things are made mostly of sugar and a little bit of protein and carbs. They go into the root system. The plant actually pulls it down, and those exudates are actually food for microorganisms, organisms that we can't see but that are there working at the bacterial level for us. And that goes to show when you actually are looking at it under a microscope, you'll find most of the bacteria and fungi in soil are located around the root systems of the plants. This is not by chance. It's because the plants are who is feeding this bacteria and fungi. So these are exudates that are specific to the plant. So you have this symbiosis happening between the plants and bacteria and fungi underneath in the soil. They'll actually grow around the root balls, and they'll create walls to protect the roots from pests, disease, and problem organisms. So if you have a good symbiosis happening between the plants, the bacteria and fungi under the soil, you don't need pesticide because you actually are just employing the natural pesticide through this relationship. So how do we attract these organisms in mass to our garden? It's through compost. So in that way, compost is not a fertilizer. It's actually an inoculum of the organisms that you need to put back into the soil to allow this cycling of nutrients to happen. Now, healthy plants need aerobic conditions. That means with air. Anaerobic conditions attract anaerobic organisms, which are disease causers, and they also drop the pH of soil, which is dangerous. So for both those reasons, when I talk about compost, I'm talking about aerobic compost. There are a few systems of composting that employ anaerobic conditions, but I really am just going to focus on the aerobic one because that can be most clearly explained this way. And anybody who's just getting started, I think it's really important to start with an aerobic compost as well. So under anaerobic conditions, you also have all of your nutrients like nitrogen, phosphorus, and sulfur. Those things are being converted into gases and leaving your soil. So if all of our nitrogen is leaving the system through becoming a gas, it's very hard for the plants to soak up that nitrogen, which is a macronutrient, very important to the life of the plants. So we really need these microorganisms because they're going to go and eat those exudates, and they're going to hold those nutrients in their bodies. And that is really important to how we keep the nutrients in the soil, is the presence of these organisms actually eating those nutrients and holding them. So one last way that nutrients may be leaving the soil is through surface water. 80% of inorganic fertilizer actually leaves the system and actually doesn't soak into the soil itself and ends up going downstream and damaging other people's farms and wells, and a whole host of other issues can come with inorganic fertilizer, and the fact that it's actually not symbiotic with the life under the soil. And this is why there are constant calls to put higher and higher amounts of inorganic fertilizer in industrial agriculture, because they're noticing that, yeah, they're dumping all of this fertilizer and the plants aren't responding. It's not staying in the soil. So the, agrochemical salesman is telling the farmers, yeah, you need more of it, but that's not actually true. So back to the bacteria. Now they've eaten these exudates and they have these glues that pull small particles together. And it builds a place for them to live and hold these nutrients in the soil. And the fungi work with them because they grow these long strands of mycelium that take these particles made by bacteria and pull them together as macro aggregates you can see. And if you've ever looked at some wood chips or been in the forest and actually seen mycelium, this is the mushrooms are the reproductive organ of mycelium is the actual organism, and mycelium, it deserves a podcast in and of itself, and maybe I'll get there at a different time. But mycelium is something that you can actually observe and see. It can be as thin as one cell wall thick, but sometimes you'll see strands in the soil that are definitely something observable with the eye, and that is always exciting because you know that they're in there working with the bacteria, creating a home for themselves. And this creates a structure underneath the ground. Mycelium is very strong, and this helps move water through the soil system. And that is really important to preventing erosion, because if you have soil compaction where there is no fungi structure, water will hang at the interface. It will hang at the surface. It will puddle there, and then it will go downstream and erode soil with it. So that is, very, very important that we have fungi in the soil, because they are the ones who create the architecture underneath. And their architecture is very important to making sure that the roots and that these microorganisms have access to water. Water is very important to our composting process. So when we talk about erosion, we're really just talking about a consequence of damage that we've done to life in the soil. Because if that life is not there, you have no biology there creating this civilization, and it compacts and becomes what we call lifeless, dead dirt. So the nutrients have been sucked up by the bacteria, and they're held in place by the fungi, living underneath the root ball of your plant. So how do the nutrients become available to the plant? So far, all you've heard is that the plant gives something to the soil, but now how is the plant eating? So we have to continue looking at the soil food web. And who eats bacteria and who eats fungi? Protozoa do. These protozoa, releasing nitrogen, phosphorus, sodium, magnesium, boron in the proper balances for your plant. So your protozoa is going to go and eat your bacteria that just ate those nutrients from the plant, and its excrement actually becomes these plant-soluble nutrients that are in the proper balance for your plant and are available to your plant. This release happens right in the root zone, so the plant doesn't have to work hard to eat, and this is what we call the cycling of a plant's nutrients. So that's the completed cycle. Basically, the plant gave sugar to the microorganisms. Those microorganisms ate it and lived in the soil, and then their predators came and ate them, and their output is actually plant-soluble nutrients. So similarly, the fungi are eaten by nematodes and microarthropods, which again release the nutrients right where they need them. So when we have a garden that holds and retains nutrients in bacteria and fungi, and then protozoa, nematodes, and arthropods eat those bacteria and fungi, our plants are getting what they need. They're getting the nutrients that they need through this natural cycling, through the symbiotic relationship. And the soil food web is held in balance through the predatory nematodes, the macroarthropods, the birds beyond that. The system continues to go on. So that is really the process of what when I'm saying, yeah, you should start composting, like, what the fuck are you talking about? This is what I'm talking about. It's really to get those micronutrients into the soil, get those microorganisms to eat those nutrients and cycle them through so that the plants can get what they need. And this way, it's completely sustainable. It suppresses disease. I don't use pesticides. I don't have erosion or problems with watering in the summer. My soil stays really moist even if it's 90 degrees out that day. I retain nutrients, and I'm constantly making them available to plants through this process. Decomposes toxins, and it builds the structure of the soil, which again is just so important to what you get above the ground. And I feel like that's just something that in gardening, it's not necessarily revealed to us that the soil is as important as it is. And we're constantly told that we need to fertilize by adding nutrients into the soil as if those nutrients aren't there. And the truth is, in soil, in bedrock, clay, sand, silt, all of these rock-based nutrients that are in the soil are there. They're not going anywhere until you run out of rocks. You really are going to have those nutrients, but what is it? Really important is making them available to the plants. That's the issue. We've not allowed for the mechanisms to flourish that take those nutrients in and convert them to food. So those nutrients aren't in plant available form, so they might as well not be there, you know? And so agriculture that damages life in the soil is very problematic, as you could probably tell, because this process can't happen. And that has a lot to do with capitalist farming. It has a lot to do with industrial agriculture. And also the growing administrative class in agriculture, meaning, you know, these big, giant pharmaceutical firms are actually the ones in control of seed patents. So there's a lot of danger when it comes to that. So I hope that this gives you sort of an insight into how the composting process actually works, and I feel like that's enough of an introduction to show you why it's important to growing good food. And I guess from here I can go ahead and explain exactly how to construct and care for a compost bin. Now that we know what compost is and why it's important, we can talk about how we construct a compost bin. Now, you may hear many different terms around composting: hot compost bins, cold bins, an indoor bin versus an outdoor bin, an aerobic versus an anaerobic bin, compost tumblers, vermicompost, bokashi compost, no-till gardening. These are all nebulous terms, but I want to sort of break them down so that you can get an idea of, you know, what type of compost is right for you. The first I can talk about is the hot bin versus the cold bin. Really, you have one compost bin. You can either make sure that you're turning it often enough to get it really hot, and that just means that the energy that these microorganisms are putting out is copious and it actually is creating heat. And the other option is a cold bin, which is basically where you dump your food scraps in and you keep adding on and covering. And it just, over time, you're going to see it attract the right organisms, but that process may take longer because you are just leaving it undisturbed and you're not really helping it along. As far as indoor and outdoor bins, I've had both, and I would definitely, if there is any way possible for you to get it outside, that's really where you're going to pick up all of those different organisms that you really want. Because it's not a sterile place like inside your house maybe, but really that's up to you, and you can manage this process through either an indoor or an outdoor bin. Same thing with a tumbler. It just means that it makes it easier for you to turn your compost, because instead you're just tumbling this apparatus that's you know, made to do that. And we definitely employ what we call a vermicompost, which means that we add earthworms to our compost because they are great eaters and they are going to eat that food material and break it down for us even faster. And their excrement, which is called worm castings, is considered one of the greatest compost that you could get. So that, and the fact that my home has chickens, so we have another added component of chicken manure, very high in nitrogen. So there are a bunch of different types of compost, but really just focus on, you're going to make a bin. What is that bin going to look like, and is it going to be inside or outside? I have constructed many different types of bins outside, and some of the easiest ones I would say are chicken wire mesh circle. So you can take a roll of chicken wire and roll it into itself until you have a circle made out of the wire, and you can start your compost in there. I like that because it's naturally aerated, because it's not airtight on the sides like a wood bin would be. So this allows air to really flow through the pile as it's cooking. But I've also created wood bins, which ours were created out of pallet wood. We're just taking 3 pieces of pallet wood, putting them together to make an open-facing bin, and starting to dump compost that way. And also through just regular old heaps and plastic bins. Now these are all options. It really just depends on, what type of outdoor space you have, and also what type of setting are you in. Are there going to be a lot of animals that are going to be attracted to this and want to come and eat from your compost? And rats and things like that are a concern because you don't want their excrement in the compost. So things like that really can help you sort of figure out what type of compost bin is best for you. The second step after you've actually constructed your bin is to fill your bin. And you can start filling your compost with equal parts green and equal parts brown material. So your green materials are high in nitrogen and your brown materials are high in carbon. So those are the 2 magical elements that you need to make a good compost. When all is said and done, you need nitrogen and you need carbon, and everything else is going to come along the way. So some examples of green items that will be processed in your compost could include weeds, excess leaves from the yard, green leaves, things like manure, chicken, rabbit, pigeon, horse manure, fruits and vegetable scraps, coffee grounds, tea leaves, any kind of vegetable plant remains. Those are all green materials, grass clippings, things that have water to them. And then your brown materials are sort of like the fiber for your compost. Those could be fall, like autumn leaves that are dried, any dead plants that are dried, sawdust, old flowers, hay, newspaper, cardboard, paper towels, paper bags, cotton clothing, eggshells, human hair. All of these items are considered brown items, and pretty much you're going to want a 50-50 split between your green items and your brown items. When you have this 50-50 split, you should have a compost that smells good. If you're turning your compost and maintaining it properly, your compost shouldn't smell like a garbage can. And that's actually a sign that there is an imbalance going on if you smell something bad. But that can be corrected. Basically, you'll start to learn if there's too much green material, it will start to smell sour and have a lot of water to it. And if there's too much brown, you're not going to smell much of anything, and it's going to be very dry. So if it's swinging too much one way, your solution is to add extra of the other. So if it's smelling bad, you're going to add dry material. If it's too dry, it means you need more kitchen scraps and you need more wet material. And speaking of wet to dry, you need to water your bin and continue to water it, because when you have a dry condition, you can't allow for these microorganisms to flourish and reproduce. So even if you're adding more green material, if you feel like it's still too dry, you can always water your bin and continue to water it. The hotter that it gets, the more microbes are expending energy to break down your pile. So the more often that you want to turn it, you're going to get higher temperatures that way, and you're going to increase airflow inside of the compost bin that way, and all of that is going to facilitate this process faster. So it's really just about what you can manage and what you'd like to do. Really, you could just keep setting it and forgetting it, and then eventually sift it, or you can go through and actually maintain it often through turning and watering, things like that. So one of the last things that you could do to get started with your compost bin after you've done you can either do lasagna layers, or you can just mix it in evenly. That's just completely up to you. I've seen people do both, and I've done both, and in the end it all ends up as compost. But one last thing that you could do is get starter compost from another bin, which is basically an inoculum of microbes already. Or you can go to your local garden center, order them online, but you can get red wiggler worms. Those are earthworms that are really going to help you break down your material. So, you can keep turning if you want a hot compost, or keep adding material if you want a slower breakdown. And I recommend covering with a plastic garbage bag or paper bags from the grocery store, because that helps hold in moisture and increase the heat in your pile. Now, that's pretty much it. Your simple compost, and I hope that doesn't seem like too much of a commitment, because it's really, otherwise you basically just throw these things in the garbage, and there's not a chance for it to do some good. So I really enjoy the process of composting, because now when I throw away food elsewhere, it feels very wrong and strange to be throwing it away, because to me it seems like such a golden material. Now, there are a few things that you do not want to compost because of hygiene and inability to break down. Now, there are exceptions to this, and because I have the element of the chickens, it's a little bit different for me. But if you're just getting started and doing a compost, I don't recommend adding meat scraps to it. I would add bones. That is a little easier on the system, but really meat is going to attract those anaerobic organisms. Those are needed to break those down. So I would avoid meat. I would avoid oil. Definitely don't add pet feces or human feces, because we have certain pathogens and our pets have pathogens that you do not want. And really, any manure from any animal that eats meat shouldn't be added unless you really know what you're doing and how long that process is going to take. Nothing like diseased plants or glossy paper, coal ash from a fire that has had accelerant on it, or cat litter. Those things, unfortunately, should just go in the garbage. And that's basically all you need to know to really get started: what to put in, what not to put in, and how to construct it. And then over time, you're going to watch it break down, and once you see a significant breakdown, then it's time to actually go ahead and sift your compost and get your reward, and then plant your plants in this amazing substance that you've created. And I use what is called hardware cloth. It's like chicken wire, except it has a much smaller hole, and the hole is just little squares, a 1/4 inch or 1/2 inch squares. So I use hardware cloth to sift my compost into a new bin, and I sort of take the unfinished compost out, I put it on the hardware cloth, and then I knead it over the cloth so that it actually goes through it, and it dumps into a bin. And then I have my sifted compost, which I can use for pots or my raised beds to feed my plants. And really, the signs of a good compost are that it smells good. It smells like dirt. It should should be coming off the top, so you can see that those organisms are working. And then when you stick your hands in it, like, you should really see not just the earthworms that you've put in there, but a multiplicity of organisms should be in there. I see millipedes and all different kinds of flies, and you should see worm eggs and little worms and big worms, and you really want to see that there's life going on under there, and that will become very exciting for you, as time goes on. So I hope that can, help someone who may be interested in getting started. And really, you can start small and start managing it, And as time goes on, you feel more comfortable, you can sort of up your game and move to the next step, or try a new method and see if that helps your breakdown faster. So I think that's all I'm going to have for you for today. And if you have any questions about composting, you can absolutely contact me. I would love to hear from you, and I'm always here for, advocating for composting and helping people get started. So yeah, definitely, just give me a shout if you need me. Thanks for listening. If you liked the show, share it with someone you love. This concludes episode 2 of the Someone Somewhere podcast. Until next time, happy composting.